Okay, hi guys. I'm going to look at a question that you struggled with, exercise 2D, question 7. Okay, really difficult question. I really want to make sure you understand this completely. Okay, so if you didn't, which to be honest should be most of you, I'm very surprised that you didn't understand absolutely everything in here, because there is something new that I need to introduce that you might not have realised. Okay, so what happens to h of x when x approaches 2? Okay, so you can see when x is 2, when x is 2, what do I get for my function h of x? Well, h of x will become on the top 2 times 2, 4 plus 5. And on the bottom, it becomes 0, 2 minus 2. Now, we know that if we divide by 0, we get an infinite answer. So, as x approaches 0, h of x will approach to infinity, i.e. you have an asymptote. Okay? Remember, an asymptote is that dotted line where, so for example, if I just give you an example of an asymptote, if you have something like this, okay, where this line and this line will be asymptotes. Okay, we're going to look at what this graph looks like in a second. Okay, so as x approaches 2, h of x approaches infinity, i.e. it's undefined. You can see it's undefined here. Okay, so this is your domain here. This is your domain. X belongs to all the real numbers, but x does not equal 2, because when x is 2, we have an undefined function, because there's an asymptote there. Right, what we're going to look at next is finding h to the minus 1 of 3. This comes in the next bit. H to the negative, i.e. the inverse function, h to the minus 1 of 3 is your inverse function. So what we're trying to do, if we've got this mapping, okay, of h, okay, so whatever value here we've got of x maps into 2x plus 1 over x minus 2. This is your mapping of h. Now what this is asking for, okay, here, what value here will map back to 3? Okay, this is the inverse function going backwards. This is the inverse function. So if this value here is now 3, i.e. h of x is 3, okay, what value of x will go back to get me 3? Okay, so to do this, what I'm going to do is just solve this to find x. So if I take x minus 2 to the other side, I get this. I'm just going to solve now, multiply out. I get this. And then 3x minus 2x is 1 plus 6. So x is 7. So if I put 7 in and put it into this function, I will get an answer of 3. Okay, so when x is 7, this answer here, let's just check that, 14, I get 15 on the top, and I get 7 minus 2, 5 on the bottom, which gives me 3. So when 7 goes in, 3 comes out, the inverse function, i.e. if I put 7 into x, out will come 3. Now, there was another way of doing that, and I might have confused you slightly. There's another way of doing that, was to find h to the minus 1 of x first. Okay, so let's look at that. We're going to do it a different way now, which you may prefer. So, you're told that h to the x equals 2x plus 1 over x minus 2. Now, the way I showed you to find your inverse function is we say that h of x is equal to y. We rearrange now to get x equals. So we're rearranging to find x. So let's bring this to the other side. Let's multiply out. Right, I want to find x equals. So I want to make x the subject. So let's move all my x's to one side and everything else to the other side. This should be easy algebra for you, okay? This shouldn't be a problem. So now I'm going to factorize to take out my x. And now I'm going to take everything that's not x to the other side. So I've now rearranged. I've gone from y equals to x equals, from y equals to x equals. And my last step now is just to write this down in terms of my inverse function. So my inverse function, I replace the y's with x's. It's just a little bit of a cheat here. Okay, so here is my answer. My inverse function of h of x. Okay, now if we look back at the last question, if you wanted to find this, all we have to do is put 3 into the inverse function. So I've got 1 plus 6 over 3 minus 2, which is 1. So I've got 7, which was my answer. X will equal 7 to get, the inverse function of h to the minus 1 of 3 equals 7. Okay. Now, the second bit to this was finding the domain of, and this is the bit that some of you told me you got stuck on, so I've starred it, okay? So, how to find the domain of a function? Well, let's go back to the beginning of h of x. Right, I've been given the domain of h of x, which would be the same as the range of its inverse function. But I've not been asked to find the range of the inverse function. I've been asked to find the domain of the inverse function. So what I'm going to do here is sketch the graph. Okay, that's the best way of doing this. And this is the tricky bit. So let's see how we get on with this. And I don't think so far you've been asked to sketch a function like this before. So let's look at what the forwards function, the h of x, looks like. Now, at the moment, in this format, I have no idea what this is going to look like. Now, I've got here an improper fraction, or a top-heavy fraction. I'm going to change it so that it's no longer top-heavy. So this means x minus 2 is divided into 2x plus 1. Remember, we did long division when we looked at partial fractions. And this is what we did in the transition when you were thinking about A-level maths way back when you were year 11 after your exams. We did this in that taster lesson. Okay, so we say x goes into 2x twice. Then I times this with x minus 2. 2 times x is 2x. 2 times minus 2 is minus 4. I now subtract these. So I get nothing, add 5. 1 minus 4. 1 add 4 is 5. That's long division, algebraic long division. Right, so I've stopped here because now this the degree of the 5 is less than the degree of the bottom. This degree is nothing, there's no x's, this degree is 1. This was an improper fraction because the degree of the top was 1 and the degree of the bottom was 1. So what do I get? So h of x is the same as saying 2 wholes plus a remainder of 5. And the remainder goes what we were dividing by. So now I've changed my h of x into something I can now sketch. I know how to sketch this using transformations. So what I'm going to do is I'm going to start and look at this function, 1 over x. Then I'm going to look at, these are the steps I'm going to do. Then I'm going to do 1 over x minus 2. Then I'm going to do this step here. And then I'm going to add 2 to it. So I'm going to look at these 4 stages. Stage 1, 2, 3, 4, to sketch the graph. These 4 different transformations. So 1 over x is this curve. You should know that, the reciprocal. Asymptotes on the x and y axis. Right, what happens, so this is, I can call this a new function f of x. Okay. Now, to go from stage 1 to 2, I'm now doing f of x minus 2. Yeah, that would be this. So how do I get from f of x to f of x minus 2? Well, the whole graph will shift 2 to the right. Yeah, the whole graph, I just pick it up and move it 2 to the right. So now my asymptote will be here at x equals 2. It was here at x equals 0 and it's moved to x equals 2. And my graph will now be like this. This asymptote stays where it is. It's just moved. I picked up my graph and moved it 2 to the right. Right, that's stage 1, stage 2. Right, stage 3. Right, what happens in stage 3? Well, I'm now doing f of x minus 2 timesing it all by 5, which we know is a stretch. It's a stretch, a vertical stretch in the y-axis, yeah, pulling it up. So if we look at this graph here, okay, so this is my stage 3. This is what the graph looks like. And now I'm just going to stretch it all up. So to be honest, it's going to look the same, just stretched higher. So it's just going to be like this, okay, just a bit more stretchy. But to be honest, it's almost the same, okay. So that's my 3rd stage. Now, my last stage, I'm adding 2 to what I've just done. So if I'm adding 2, the whole graph is now going to move up 2. So let's see what that's going to look like. My whole graph is going to move up 2. So let's just sketch the graph. So this asymptote will stay the same. X equals 2. My y, this asymptote here at y equals 0 will now move up to y equals 2. So my graph is now going to look like, let's just move this, make these asymptotes bigger. Okay, just make the x and y axis longer. So I'm just moving it up and this will be my final graph. And this was called originally h of x. So there's my sketch of h of x. Right, we've probably forgotten what the question is now. Okay, what were we trying to do after? But I wanted to spend time on that because sketching transformations is so important. It comes up so many times. So you were asked, I'm just trying to find, guys, where's the question? Let me find the question. I'm gonna pause. Okay guys, I'm back. I've found the question. Right, the question was find the domain, okay, of the inverse function. Right, so this is my original function. The domain of the inverse function is exactly the same as the range of the original function. So what's the range of this function? Well, the range goes this way. What's my range here? Well, my range will be h of x exists for all numbers apart from 2. Okay? So, the range of this is the range of h of x. H of x exists for all the real numbers, but h of x does not equal 2. So that's the range of h of x. This will be the same as the domain of my inverse function. We just write it like this. So the domain of my inverse function is x belongs to all the real numbers, but x does not equal 2. Ho ho! Hooray, we got there. Right, there is one final bit, guys. Right, this is the final bit. Find the elements of the domain that get mapped to themselves by the function. Woo! What does that mean? Find the elements of the domain that get mapped to themselves by the function. Basically, that is saying anything you're putting in to the function is equal to when you do the function on it. Okay? Now, we know that my function is 2 lots plus 1 over this. Yeah, this is what you were given at the beginning. You were given this. And you want to know when you put in a value, you actually get the same answer back when you put it in. So that's why you're solving this equation here. So we're going to solve m now. So let's take everything m minus 2 to one side. Let's multiply out. Now we can see we've got a quadratic. Okay, so let's make our quadratic. There's my quadratic. It does not factorize. I'm going to solve it by completing the square. This should be easy for you. Okay, and then I'm going to work out and rearrange to get m. So plus or minus the square root of 5. So m is 2 plus or minus the square root of 5. So there was 2 values that if I put it into my function, I get the same answer out. So if I put this 2 plus root 5 into here, I will get out 2 plus root 5. I'll just verify that for you. Okay, so h of x equals 2x plus 1 over x minus 2. If x is say I'm putting this in, okay, so what do I get? i.e. what's h of 2 plus root 5? Well, I've got 2 lots of what I'm putting in, 2 plus root 5 plus 1 over 2 plus root 5 minus 2. So what I did there, I'm replacing the x, okay, with 2 plus root 5. And I should get, this should all simplify to 2 plus root 5. Let's just double check that, guys. So let's multiply out. So I've got root 5 on the bottom. Okay, so I've got 5 plus 2 root 5 divided by root 5. So that's 5 divided by root 5 plus, and you can see we're going to get there. Rationalise this, I'll just get root 5 plus the root 5's cancel. Okay, so just to show you the rationalising, times top and bottom by root 5. So I've got 5 lots of root 5 over 5, which is root 5. Bit of side working there. Okay, so h on 2 plus root 5 gives me 2 plus root 5. So that goes back to find the elements of the domain that get mapped to themselves by the function. And if I was to put 2 minus root 5 in, it would come out to be 2 minus root 5. You can try that yourselves. Okay, that was long, but thanks for listening. Bye-bye.